Right, let's plot this quadratic function. We can see that it's over here, it's written in expanded form. That's really useful because straight away we'd be able to identify the y-intercept. And in this question, what we'll do is we'll just pretend that we're being asked to identify and label the y-intercepts, the x-intercepts, and the turning point. You might not always be asked to find all of those, but this is how you find each of them, or one of the ways anyway. The y-intercept's really easy to identify when it's in expanded form. Just like in linear, it's the constant, it's the number on the end. So we know that the y-intercept happens that when x is 0, y will be 8. And we can mark that at 8. Next, we need to find our x-intercepts. And one of the ways of doing that is to use null factor method. So when we're finding the y-intercept, we said when x is 0, what is y? But when we're finding out what the x-intercepts are, we make y 0. So in this case, we're going to say 0 equals. And now I'm going to factorize the equation that's above. What are the factors of 8 that make 6? They are 4 and 2. Are they positives or negatives? I'll have a little look at this symbol here. It's a plus. That means that they're both going to be the same. And that one tells me that they're both going to be negative. So we've got a -4 and a -2. So the x values will be 4 or 2. And what that means is that our x-intercepts are x will be 2 when y is nothing, and x will be 4 when y is nothing. So now I've found my two intercepts on the x-axis as well. And the last thing I need to find is the turning point. Now, one way of finding the turning point is to find what's halfway between 2 and 4. And in this case, it's obviously 3. But if you got dealt with difficult or got handed difficult numbers to deal with, you can just find out halfway between them by adding them together and dividing by 2, which will give you 3. Now, that's not the turning point. That is just the x value of the turning point. We still don't know what the y value of that is. So what you can do is you can take that 3, because it's an x value on the line, and you can substitute it back into the original equation, okay? So what we'll do is we'll say, great. So if x is 3, y will be 3 squared minus 6 times 3. Made a mess of that. 3 squared minus 6 times 3 plus 8. And remembering your order of operations or BODMAS, it's orders first or brackets first. There's no brackets here, so orders, then multiplication, then addition. Okay, so it's going to become 9 minus 18 plus 8, which would give us -1. And so our turning point will happen at 3 minus 1. And then to plot them, we've put all our points on our Cartesian plane over here, and then not with a ruler. You freehand just the best curve that you can through. You don't use a rubber halfway through. You freehand a curve as best you can onto the Cartesian plane, and that's been plotted. We'll try and do another one. Okay, in this second example here, we are going to do the same thing. We're going to find the y-intercepts, or the y-intercept, the x-intercepts, and the turning point. And this is another expanded form quadratic. It looks a little different because you might notice that it's missing a constant here on the end, okay? And that's what we'd use to inform us of our y-intercept. So if you can't see it, it's because it's a 0. So that means that your y-intercept is 0, 0, or when when y is 0, x is also 0, vice versa. Okay, so we are saying here, what if x is nothing? Well, nothing squared plus 2 times nothing is nothing, so y is nothing, so 0, 0. And now to find our x-intercepts, it's the same process as above. We're going to factorize this, and we're going to make it equal 0, so null factor. So really what we're saying here is if y is 0, I can find my x-intercepts. And if I factorize this, it looks like this. So I know that my x values are 0 for this one here, or minus 2 for this one here. So that means that my x-intercepts happen at where x is 0, y is 0, same as the y-intercept above. And it also happens that when x is minus 2, y is 0. And so I've got my 2 points. So I can start plotting these on. This is both my y-intercept and my x-intercept. And my other x-intercept occurs over here at minus 2. And now what I need is my turning point. So halfway between 0 and minus 2 is minus 1. But if we need to work that out, we can go like this. 0 plus minus 2 divided by 2 gives me minus 1. So I know that my turning point down here somewhere is going to happen when x is minus 1. And now I just don't know what the y value is. So I take my x value of minus 1, because it's on the line, and I substitute it into the original equation so that I can work out what the y value is. So I say y equals 1 squared, minus 1 squared, and be careful of your calculator with that one, plus 2 times minus 1, and what you'll end up with is 1 minus 2. So this one also has a value of minus 1. So my turning point is at minus 1, minus 1. Freehand my curve in best I can. I've marked all the points. Well, technically I should go like this, like I should have done up the top here. Okay, and that's your answer.